Hello, everyone, and welcome to the free GRE Prep Hour. Very excited to have all of you with us. We have lots of exciting stuff to talk about this evening. Here is what is on our agenda for the evening. We are going to be looking at cracking the code. So a lot of what's difficult about the GRE is not actually solving, it's figuring out what the questions are really asking. It's cracking the code and figuring out what the question is really asking. So that is what we're all about tonight. And we're going to talk about how to make quant flashcards. I know a lot of you probably have made a lot of flashcards for the verbal side for vocab. Definitely that's the best way to memorize the definitions of tough GRE vocab words. But a lot of people don't realize that flashcards can also be really helpful for math concepts as well, especially the ones that really aren't about solving, but that are about translating. So welcome all of you. Very glad to have you all with us. We have a chat function here. You're welcome, if you are attending live, to type questions in the chat, and I will try to address those if I can. If you are watching these on video later, obviously can't respond to those chats, but you're welcome to join us the next time we have a free prep hour. So for those of you with us here, why don't you go ahead and type in the chat window and just tell us where you're dialing in from. I am in Brooklyn, and it's nice and cold here. There's definitely a cold that's going around New York, so if my voice sounds a little scratchy, that's why. Um, all right, we got folks from all over the world, all over the US. Awesome. Well, welcome. So great to have you with us. Um, and how many of you have taken the real GRE before? All right. A couple of you have taken it once, at least someone took it twice, someone took it 7 years ago. All right, so I'm going to assume that the rest of you are pretty new to this, just starting out your studies. Regardless of where you are in your studies, I hope you'll find this helpful. The problems that we're going to be using are modeled after problems in the 5-pound book. So I'm certainly not going to try to tell you that you have to pay for a class or go out and buy things, but if you want lots of practice on problems like these, this is a great thing to pick up. It is a giant book full of lots and lots of problems to practice with and great explanations, all written by Manhattan Prep instructors. So why don't we just dive right in? We're going to work on some problems all together. What I want you to do me a favor, don't type your responses in the chat window. Give everyone else a chance to work on the problem. And after about a minute and a half on each problem, we'll then discuss. So go for it. All right, I gave a little explanation here for those of you. There may be some of you who've never seen QC, as we call it, Quantitative Comparisons questions. These are a question type that's unique to the GRE. These will be about 7 out of every 20 questions in a quant section. And there are always 4 answer choices with these. It's either going to be that quantity A is greater, or quantity B is greater, or they're equal, or we don't have enough information to tell. So this is a type of problem that often involves more translating than solving. You might not be able to figure out what the values of the given variables are, but you might have enough to compare the two quantities, even if we can't figure out what the values are. So are there anyone out there total newbies and never seen QC questions before? All right, so it looks like everyone has at least some familiarity. All right, we got one newbie. That's fine. Hopefully this will be self-explanatory. But our job when it comes to QC is first, we want to unpack the given information, what we call the upfront information here. So unpack this first, and then once we've translated, unpacked what's going on here, then we can address quantity A and quantity B, pick numbers if we need to, or simplify further from there. There are recordings of previous free prep hours that deal specifically with QC process. Definitely recommend checking out those. There's one I did about avoiding traps on QC, avoiding the easy C, so definitely check those out. But for our purposes here, what we're going to be doing tonight is really focusing on this idea of unpacking, translating the kind of coded information that the GRE likes to give us. So here's what I'm going to do. I'm actually going to break this out and just take each piece of information piece by piece and see if we can decode it. And in fact, if you have a stack of index cards sitting anywhere near you, I highly recommend making flashcards for these. So here's what we want to look for when we are decoding tough GRE language. First, we want to think, all right, well, what do we recognize? In this first one, I'll tell you what I recognize. I see an inequality sign and then 0. So that is a big old signal. Ooh, someone's saying that they can't hear my audio. Hang on. One moment. Can other people hear my audio, or is it just one person? Okay. So, okay, if other people can hear, then hopefully, Shaha, you can fix what's going on with your audio. But please do tell me if there are any issues that you guys come across in the future, because it could be on my end. So, translating. Couple of things that we want to do. One is just tell ourselves, what do we notice? So there are some clues about what topic is being tested. If we see a less than 0 sign or a greater than 0 sign, oh yeah, I'll give you the link to the other videos for sure. What topic is being tested if we have a less than 0 sign or a greater than 0 sign? Well, less than 0 or greater than 0, it's testing positives and negatives. Exactly. So sometimes, don't worry about solving it. Just identify what's going on, what topic are they getting at. And then other things that we want to notice, okay, positives and negatives, I want to think about exponents with positives and negatives. So in each of these, we have a greater than 0 or a less than 0, but we've got different exponents going on in each. So then we tell ourselves, all right, what are the rules? With exponents and positives and negatives, what happens if we have an even exponent? Regardless of what the base is, Ooh, I'm going to push back a little bit. I'm going to say you're almost right. Some folks are telling me in the chat that if it's an even exponent, it's always positive. There is one exception. When would something squared not be positive? Don't worry about imaginary numbers. With real numbers, there are positives, there are negatives, but there's also zero. Exactly. Don't forget zero. If we have an even exponent, it's positive or zero regardless of the base. Got more than I can fit in my flashcard here, but that's all right. So, and if it's an odd exponent, so even exponent hides the sign of its base. And so then an odd exponent takes the sign of the base. So that's our rule. So then how do we translate? Well, maybe let's go to the second one first with that even exponent. Over here, if a squared times b is positive, well, what we know about a squared is what? Positive. And so an even exponent has to be always positive or zero. Why can't a squared be zero in this case? Well, if it were zero, then the whole product would be zero. But if the whole product is greater than zero, then it means neither term is zero. So we know that the a squared must be positive. And if a positive times something is a positive, what does that tell us? Aha. So a squared is positive. That tells us nothing about a, really. A could be positive or negative, but b must be positive. If a positive times b is positive. So the way that you could write this, you could write it out like this in words, or you might just say b positive, a unknown. And that's how we would translate this code here. So what you would want to do is, I'll just erase this messy stuff on front. If this was the front of your flashcard, a squared b greater than zero, on the back, you could put all of this stuff about the topic and the rules, depending on how big your handwriting is. But the real key is just this translation. It tells us something about b, but doesn't tell us anything about a. All right, now the first one was a little bit more complicated because we had a times b cubed. And remember that a, just by itself, it's implied a to the 1, so an odd exponent there. So if an a to the 1 times b cubed, both odd exponents, if we get a negative product overall, what do we know about a and b? Someone's telling me that one of them has to be negative and the other one has to be positive. So we either have a negative times a positive or a positive times a negative. We don't know which one just from this statement alone, just from this inequality alone. But another way of saying that is that A and B have opposite signs. So these are our two bits of code, our two translations. A and B have opposite signs, and B is positive. So therefore, putting the two of those together, we can conclude B positive and A negative. And if that's the case, what is greater, quantity A or quantity B? we don't know what the actual values are, but it doesn't matter. Quantity B must be greater if it's positive, but A is negative. So testing values wouldn't have been very time efficient here. Trying to combine these algebraically would not have been efficient here. Things can get very messy when you try to combine inequalities if you don't know your signs. Instead, we just want to translate the code. What is it telling us about positives and negatives? So I'm going to let you guys practice a little bit with that. Take a stab at these two. All right. Sorry, excuse my voice. Let's take a look at these. So here again, we've got some greater than zero signs. So definitely testing positives and negatives again. So how would we translate x, y, z greater than zero? If we have a product of three things greater than zero, what do we know? When do we get a positive when we multiply three things together? Aha, we could have, it's important to specify either all positive, or don't forget about the scenario of two positive, or sorry, rather, two negative, one positive would give us a positive product of three things. So, taking that idea, we now get a layer even more complicated. We've got this product here, q cubed, that's fun to say, isn't it? R to the fourth, s to the fifth, greater than zero. All right, let's break down piece by piece. What do we know? Is there anything we know for sure is positive or negative? Yeah, r to the fourth has to be positive. What does that tell us about r itself? If we're writing this out, r to the fourth is positive, and that tells us that r is positive? Not necessarily. That fourth power is hiding the sign of the base, so r is unknown. It could be positive or negative. So then what has to be true about q and s? They could both be negative, or they could both be positive, and we get a positive product either way. And since odd powers take the sign of their base, if q cubed and s to the fifth are either both positive or both negative, then q and s have to be the same as well. So we would say q and s have the same sign. All right, you guys did great with these. Let's try a few more. Um, let's do this. I'm gonna clear these. Let's do, I'll just make some new flashcards here. How would you translate, let's say, AC squared over B cubed is negative. And then translate, try those. So notice that I kind of just made these up on the spot, right? When you're doing flashcards, practice one translation that you see in one problem, but you're never going to see the exact same problem twice. So ask yourself, what kind of iterations? How might they mix this up a little bit? So when we introduce fractions into the mix like we did here, how does that change things? A c squared divided by b cubed. Well, when we think about a fraction being negative, think about it this way. A negative fraction either needs to have a positive numerator and a negative denominator, or a negative numerator and a positive denominator, right? So what we know so far is that c squared, well, that's going to be positive no matter what. And so we can kind of ignore that. With a product, if there's something that we know is positive, we can kind of ignore it and we say, well, a over b cubed then, we're either going to have a positive numerator and a negative denominator, or vice versa. So what can we infer about A and B? Well, one of them has to be positive, one of them has to be negative. So A and B have opposite signs. And then C, we don't know. That even exponent is hiding the sign. C could be positive or negative. All right, this one down here is a little sneaky. Another way that they often test positive, negative concepts is with absolute value. So that's what I was going for there. If you couldn't quite tell from my handwriting, that was the absolute value of P in the denominator there. So what do we know about absolute values? Ooh, here's a good one for a flashcard. Sometimes you can use flashcards just for rules. Absolute value is defined as the distance from zero. And as such, distance, we never talk about negative distance, so its absolute value is always positive, or could be zero itself, right? The absolute value of zero is zero, but the absolute value of anything else, the absolute value of a negative, is positive. So similar to when we look at c squared, for example, if we're looking at the absolute value of p, but it's less than 1, so we know it can't be 0. We can't have a 0 in the denominator. We know that absolute value's got to be positive. And okay, yeah, over here we had less than 1, not less than 0. But what about this? What would be the case if p were positive? Then p divided by the absolute value of p would equal what? It would be 1. So if this leaves us with something less than 1, then this tells us what about p? E must be negative. Because if it were positive, then p divided by absolute value of p would be equal to 1, not less than 1. Cool. Great job on these. Let's just keep on going, keep on trying some problems and translating. I'm going to clear these. And by the way, feel free to take a screenshot at any point if you want to hang on to these and write them down later. I'm going to clear these, and I'm going to give you another QC problem to do here. Don't type your answer in the chat window. I want to give everyone a chance to try it out first, but we will discuss in a minute and a half. All right, we have a lot to unpack here. Not just in the upfront information, though. We've got stuff to unpack in the quantities as well. So I want to decode both of these. Absolute value of A plus the absolute value of B greater than absolute value of A plus B. All right, we know this. Whenever they give us absolute value, yeah, it's absolute value, but it's really about positives and negatives. So let's think about this. When would the absolute value of these two sides of our inequality, when would they have been equal? Like, when would the absolute value of A plus the absolute value of B equal the absolute value of A plus B? Oh, and someone was asking in the chat when we'll receive the recording. So these videos are posted on YouTube, usually about a day later, so probably by tomorrow. You can go on YouTube and find the whole thing. So if you need to sign out early, that'll be there for you. So one thing that we can do, if we're trying to decode this, if you're practicing decoding, you could set up a chart where you say, all right, what if they're both positive? Well, then we'd have a positive, 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 positive. You could test values if you wanted. You could say, well, what if it was 2? The absolute value of 2 would have 2 plus 2, and it would be 2 plus 2 over here, so it would be 4. Well, those would be equal, so that doesn't fit. And if we try one of them negative and one of them positive, you get the idea. Test out all of the different scenarios. And you'll find here that if they were both positive, these sides would be equal, or if they were both negative, these sides of our inequality would be equal. So it's got to be the case, the only situation that makes this true is if one of them is negative and one of them is positive. So A and B must have opposite signs. Is everyone with me on that? Does it make sense why they have to have opposite signs? Because then these would be counteracting each other, whereas these would be pulling the same direction. But let's look down here at quantity A and quantity B. Something important that I want you guys to notice here. I want you to pay close attention anytime quantity B gives you just a number, but quantity A gives you a product or a variable or a word problem. If you have just a number in quantity B, and it's always quantity B, they never do it the opposite way with just a number in quantity A, that means you can do what we like to call cheat off of B, or in other words, use this as a reference point. So I look at this and I say, all I'm trying to do is compare it to 0. So if I can figure out if it's definitely going to be positive or if it's definitely going to be negative, that's all I have to do. I don't have to actually calculate anything. So what you could do, I mean, this seems like a funny thing to have on a flashcard. I mean, you would have to write here like, upfront, info, redacted, if this were a flashcard, right? And how would you translate quantity A and quantity B? You could actually even just say this. Just a number means cheat off of B. So this question is clearly all about whether product AB is positive or negative. So if we're thinking about when a product is positive or negative, what would make a product of two things positive? Product of two things will be positive if they have the same sign, both positive or both negative. And a product will be less than 0, negative, if they have opposite signs. So this question is asking whether this product is positive or negative. In other words, do they have the same or opposite signs? So in this problem, our upfront information told us, well, they must have opposite signs. So then our answer, clearly quantity B must be greater because quantity A is going to be negative. But we can take this one problem, split it into 2 separate flashcards, or if you wanted, you could do one flashcard for the whole thing. You can, if you're doing a whole problem as a flashcard, make sure that you break it into discrete pieces and that you're not just memorizing the answer to that problem, but you're really signaling to yourself, next time I see this, here's how I want to do it. Here's how I want to translate it. You can put things like, tip, use a chart for positives and negatives to test your various cases, that sort of thing. Yeah, questions on this one? All right. Let's try a few more translations with absolute value and some things like that. Take a look at these. All right, let's translate these, and then we will look at questions that some folks have sent in. Okay, so here's one that I know a lot of people think looks really funny. Absolute value of n equal to negative n. Our brain sees a negative in front of a variable and thinks, oh, well, that's a negative, right? Like -2. But you want to be really careful there. If you're looking at that and you're like, wait, that doesn't make sense because absolute value has to be positive, or, well, not negative, you're right. Absolute value can't be negative. So if the absolute value of something is equal to negative n, what does that mean about n? Aha, n must be negative. So think about it. If we had the absolute value of -2, well, that would be equal to negative -2, right? So it's got to be the case that the right-hand side of this equation is either positive or 0. So if we stick a negative in front of that variable, we can't have had a positive variable to begin with, or we'd end up with a negative. So n must be negative, or is there anything that it could also be? Could be 0 itself. Because if we go -0, that's just still 0. So this might actually answer a question that someone just asked. Here, I'm gonna draw a big white box here first. We'll come back to those. So the question I was asked is, what if we have a problem that looks like, hang on, scroll up to get this question. Y absolute value less than or equal to -4. So let me, Tabasum, tell me if I am drawing this correctly. Is this what you mean? The absolute value of y less than or equal to -4? Is that what you had? Or -4x, sorry. All right, so this I think is kind of similar. We have an absolute value. We know that an absolute value can't be negative, right? So the way that I had drawn it at first, we know isn't right. If I didn't have that x there, absolute value of y less than or equal to -4, that would not make any sense, right? But less than or equal to -4x, well, let's translate it piece by piece. If that's true, what has to be true about -4x? If it's greater than or equal to some absolute value. Let's take it one step at a time. An absolute value can't be negative, so an absolute value can't be less than or equal to a negative. So we can start by saying that -4x has to be positive or 0. And if that's the case, if this product greater than or equal to 0, we can divide both sides by the -4, right? But we have to be very, very careful when we're dividing with a negative and an inequality. What do we have to do? Flip the sign. So that means that x has to be less than or equal to 0. It doesn't tell us anything about y, because y is hidden in that absolute value sign. But it does tell us that x, it's got to be either negative or 0. And honestly, the -4 was kind of thrown in there as a bit of a distraction. I bet that if you saw this on a QC question, it would just be this, and then it would be like quantity A, X, quantity B was Y, and then, if that was our QC question, what would the answer be? Well, we translated it to know that X is less than or equal to 0. What do we know about Y? Nothing. Y is hidden in that absolute value sign. We don't know anything about it. The answer would be D. Yeah. So yeah, this, what you want to do when you come across things like this is think, okay, where have I seen variations that look similar? Can I try different variations on this? Yeah, that was great. Perfectly relevant. Right. So we translated that first one. For this second one, here's how I want you to think about it. I actually want you to translate this, rather than trying to translate it algebraically or something like that. A lot of times if you have absolute values and it's not about 0, think about it on a number line. Where is this true on a number line? What kinds of numbers have absolute values that are less than or equal to 1? Numbers between 0 and 1, true. We've got all the positive fractions, and we want to include 1 itself, and we want to include 0. But there's more than that. We also want to think, what if m is negative, but then its absolute value flips around to positive? But would this be true if m were any negative, like if m were -10 or something? Then the absolute value would be +10. That wouldn't work. So it would have to be negative fractions or decimals. It would have to be the numbers greater than -1, less than +1. So you could write that like this. M has to be between 1 and -1 inclusive. Or you could write that in words if you wanted. But the real key here is, don't forget about the negatives. What about this third one? Here's another one that I think a number line would actually be really helpful for. What kinds of numbers are smaller when cubed than the number itself? All right, someone says negatives. That's a pretty common response. But my question for you is, any negative? Is every single negative out there going to be smaller when you cube it than the number itself? Ooh, Adarish is getting more specific. Less than -1. So when we think about a number line, these are the important pivot points. 1, 0, and -1. These are the most important numbers on your number line. And we also want to think about positive fractions. We also want to think about negative fractions. They'll behave in their own ways. So where is x cubed less than x? Someone said fractions, but I want us to get more specific. It's only positive fractions that get smaller as we cube them because they get closer and closer to 0. Negative fractions also get closer and closer to 0, but that's moving to the right on the number line, which means they're getting greater. So it's only the numbers less than -1, not inclusive, and between 0 and 1, not inclusive. So the translation on that is trickier than you'd think. So x less than -1 or x between 0 and +1. Non-inclusive means not including 0 and 1. So when we have the less than or equal to sign, like over here, that's that means inclusive. 1 is included in that set, so I do the solid bar. Oops. And over here, just a less than sign means I don't want to include 0 and 1. Good question. So this kind of stuff, if this were to come up on a QC question or a discrete quant question, it could come up anywhere, you want to make sure that you're thinking about all the possibilities for what it could be. Because imagine this was a QC question, and then quantity A and quantity B were, how about this? X to the 4th versus x to the 5th was what you were asked to compare. If you were only thinking about negatives, you would say to yourself, well, x to the 4th is going to be positive, but x to the 5th will still be negative, so A is greater. If you were only thinking about positive fractions, you would say to yourself, well, the larger, oh wait, I should have actually done that the opposite way. Let's do this. Let's do x to the 5th and x to the 6th instead of x to the 4th and x to the 5th. Because we would have gotten the same response either way. But in this case, x to the 5th versus x to the 6th, if we're only thinking about negatives, the even exponent is greater. If we're only thinking about positive fractions, the smaller exponent is greater. We want to make sure that we're translating accurately and thinking of both possibilities. Make sense? Cool. All right, take a screenshot if you'd like. Otherwise, we're going to clear this. And now we have a challenge problem that ties together a bunch of different number properties concepts. So give this one a try. All right, there is a lot to decode here. So I want to start with a couple things. A couple pieces of code that might not even feel like code, but that I want you to start to recognize. One is just this. If you ever see something that's -1 to an exponent. We usually don't care about 1 as a base, right? Because it doesn't do anything interesting. It doesn't change. We raise it to any power, just stays 1, right? So if you see -1 raised to an exponent, especially a variable exponent, well, what they're really testing with a -1 as a base is what? Yeah. They're testing whether it'll be positive or negative. So they're testing whether the exponent is even or odd. Because if the exponent is even, it'll make it positive. If the exponent is odd, it'll make it negative. So I always want you guys to pay attention to any upfront information, even if this doesn't give us much to unpack. N is a positive integer, not a whole lot to do with that, but given information is always important. The fact that n is an integer tells us quite a lot, actually. What does it tell us here? -1 to the 2n. As long as n is an integer, then 2n, we want to know whether our exponent is even or odd. Well, 2n, 2 times anything that's an integer must be even. So the overall expression must be positive. Can't type there. Positive, still can't type. Make sense? So let's ignore the 63 to the n and all of that for the moment. I just want to worry about the positive negative thing. So -1 to the 2n, that's going to make this positive overall. All right. Now here's this other bit of code that we'll see a lot on the GRE. If you see something that says that a given number, they might say like, you know, p equals 2n plus 1, where n is an integer. That is just a really fancy way of saying what? Exactly. It's a fancy way of saying it's odd. So over here, it looked like we were going to have to do some complicated exponent rules, but we don't. All we have to do is look at this and say, well, 2 times n has to be even, so add 1 more and it has to be odd. -3 to this odd exponent, overall it's going to be negative. 7 to the n, it's going to be positive. I'm not worrying about what that number is or how big, but it's a positive times a negative, where over in quantity A, we had a positive times a positive. I don't have to do any more calculation. If I just decode the positive negative stuff first, I know that quantity A has to be greater. So I want you guys to pay attention to +1s. They're often signals that we're dealing with even-odd rules. You might see, like, you know, k equals 4x minus 1 or something like that. That would also be code for odd. They'd have to specify that x was an integer, but they would. Yeah. So here's what I want you guys to do. Hopefully I've proven that, look, we didn't do any math tonight at all. We were just decoding based on the rules, taking the simple rules and looking at the complicated ways that the GRE likes to put them together. So when you're reviewing flashcards, you can use this for vocab flashcards, you can use this for quant flashcards. What you want to do is have a deck of flashcards, have some that you review on a regular basis, your new cards you go through on a regular basis. If you get them right, you put them into the next pile, get that right again, put it into the next pile, and so on. But anytime you get them wrong, you move them back to the first deck. Honestly, I think 5 decks might be a little excessive. I think you could do this with 3. But the idea is you space that out. It's this principle called spaced repetition. Frequently at first, and then give yourself a week, and then 2 weeks, and then 4 weeks between when you've seen a given flashcard, so that you're really stretching your brain every time to see if you can translate and decode. And then I also encourage you not just to memorize the small set of ones that we did here, for example, but to make your own versions. So if this was the one that I gave you, write your own version with new variables and different exponents, and division instead of multiplication and things like that. Make it dynamic, and remember that you're never going to see the same problem twice. So don't memorize. Think about how you can extrapolate and iterate on what you've seen. Someone asked me where you guys can find recordings of the videos, so I'm going to put that link here in the chat. But you can just go to the Manhattan Prep GRE site, right where you guys signed up for this under workshops. There's a link to recordings of previous ones. We have a YouTube channel where we have GRE vocab words of the day, and then if you scroll down, they're all the previous ones. So if you wanted more practice with QC, there are 3 or 4 different workshops on QC strategy. So I recommend checking those out. And please do come back for the next one. We are delighted to have you. And last thing I will say, you can always sign up for a Manhattan Prep course absolutely for free. You can take the first class for free, either in person or online. It's not just an intro. You can take the first session of our real course to see what it's like, to see if it clicks for you, or just to pick up some pointers. No one's going to try to upsell you on anything. We also have this really cool thing called GRE Interact. It is an adaptive, interactive self-study program, and you get a full week for free when you sign up. No pressure to sign up for more than that. We also have tons of free resources on our blog, lots of other workshops. We just want to help you do the best that you can on this test. So thank you so much for joining us. It was a pleasure to have you. Hope you picked up some good pointers, and hope to see you next time, and good luck with your studies. Take care.